So this is a typical British winter's day. We've got some sun peering through the trees and it's also raining. Now, a question that we get asked all the time is, why do people have solar fitted in the UK if this is our weather system? Well, the question really should be, what system are people selecting to have installed on their homes when they live in the UK? And if you see weather like this all the time, then maybe you should think about the system that you're having selected for your property. Now we're going to head over to one of our installs today where we're fitting REA Fusion 2 panels combined with microinverters. Now these panels are specifically designed to work in the UK environment, and that's because they're optimized for low light situations. So the answer to your question is yes, you should have solar fitted, but you should definitely select a product that's going to optimize and perform in this environment. So let's head over to that install now and we'll see how this system works and give you some more information on how a system like this can perform for you in weather like today. So we've arrived in what has turned out to be a sunny Birmingham, although there's a little bit of cloud up there. The property is just behind you here and the panels are on the roof. The battery is going into the garage at the moment. We've had a bit of a nightmare with that because we've had to run the supply. This is a Giv Energy all-in-one battery, so it's got the gateway, which means it's got full home backup. But to do that, you need to take the supply from the incoming tails and get that to the gateway. Where everything was located was a little bit more tricky than we'd hoped, so it has took a few extra days to get this job done, but we'll take a look at that in a minute. Okay, so we're now on the roof and here are our panels. They've all been installed with some bird protection. We'll come back to that shortly. Now, just to give you some background to the design on this array, what we've done is we've put 16 panels on this back roof. So the orientation of this south is about sort of there. It's 10:15 in the morning. The sun's just over, so the sun's going to come round. It's going to set somewhere in that direction over there. So this array here is going to get a lot of the morning sun, the day sun, and also the evening sun, so generation throughout the day. What we've also done is we've put 2 panels on the front. There's a little mini apex, we'll take a look at it in a minute. We've put 2 panels there, so that's going to give it some extra morning generation. Just because the way the property sort of sits, its orientation, we've just designed it in a way to get the maximum amount of generation we can. These are the REA Fusion 2 panels. Now to look at, they look pretty much like any solar panel on the market, but they are a lot different. And that's because of 2 or 3 things. One of them is their cell technology. So they're an N-type TopCon HJT cell. It's a cell basically that was designed by Panasonic about probably 20 years ago. And it used to be really, really expensive. Because of production improvements and because of the popularity of solar, production costs have dropped, and REA Australia, who actually make these panels, have now got these in for a price point which is about the same as pretty much any other high quality panel on the market. So on a traditional sort of DC panel, a direct current panel, they are designed with a very top heavy efficiency window, and that's because they're built under something called global design principles. So when you buy a solar panel in the UK, that solar panel will be designed globally to work in Spain, it'll be South Africa, North America, South America. What REA did is design their cells and their panels to have a lower optimization window, because obviously in the UK, we rarely get full days of sun, and when we do, everyone runs to the beach, and we know how rare those occasions are. So what we wanted was a panel that was going to perform when the UK environment is like this, and this is what they do. Now also what they have to improve their efficiency is they're a bifacial panel, so there's cells on the front here, but the exact same cells are actually on the back of the panels. Now it comes up all the time that people say, well, that panel's against the roof and it doesn't really make any difference because there's not, it's too close to the roof and the roof's a dark colour, it's going to absorb the light. In theory, that sort of makes sense, but in practicality, it does actually work, and we've got some testing going on at the moment in the UK with these panels where we've got standard systems, mono panels against these, and the performance difference is about 18%. Now in Australia, there's actually a research project going on at the moment with the Queensland University where they've got all sorts of panels being tested, and again they're getting a similar result. Because how it works, in between the panel here, it actually looks black, but if you come around here, Jack, you can just see, I don't know if you can see that, you can just see the frame popping through there, and that's because this intersection here is actually clear. There's my finger there. So these intersections across the panel are allowing light to come through, and if you can just see there, you can actually see little bars of light popping through the panel. So they are allowing light to transfer behind the panel, and that's being captured on the cells behind. Now when it works really well is on a really bright sunny day. The light, when it hits the panel, everyone thinks it just gets absorbed and it just bounces back, but obviously light is such a powerful energy source, it actually goes through the panel and those cells capture it on both sides. Another design feature of this panel would be the transfer window, the transfer wires. All these cells that are sat on here, these will collect energy, and then that energy needs to be transferred to something called a buzz bar, and then the buzz bar is where the energy is then transferred to the inverter. Most panels have an 8-wire transfer design, a cable transfer. These are a 16-wire design, so they're much more efficient. And our final piece of the puzzle is a microinverter. So behind every one of these panels, there is a microinverter built onto the back of the panel. Now what that microinverter does is it converts DC from the panel locally into AC current, because our homes use AC. We can't use the power from the panels directly, it needs to be converted. Normally this is done with a central inverter, but in the case of Heatable, we do this with microinverters. Now, the real advantage of microinverters is the fact that they have a very low voltage startup. So this panel has been designed to kick in at low operational light situations. I've paired that with a microinverter that also requires low volts to activate. Now, that means that we can capture energy in pretty much any condition. In fact, at Heatable, we've never had a day where we've not had generation from any of our systems, and we've actually got a system at the very top of Inverness, and that client 365 days a year gets generation. With a DC system where you've got a central inverter, they need sort of 200 to 300 volts just to turn on. So you need an awful lot of power on these panels just to get the inverter to kick over from DC to AC. On these microinverters with these panels, you only need 12 volts. So it's a fraction of what you'd need on a DC system. And what it also gives you is full panel independence. So if you come round here a minute, and just take a look up there, you can see the chimney is shading the top right hand side panel. It's casting a shadow on that panel. Now, with this system, every individual panel is its own power plant, so they're not connected to one another. On a DC system, they're all connected. What it means is if one of them has got partial shading or has, I don't know, bird poo, or it has a cloud passing across the array, then the whole system works to the lowest common denominator. So right now, even though all these 15 panels are unaffected by this chimney, if this was a DC system, all 15, or 16 rather, would be performing at the same level as that panel which has got shading. Whereas on this roof, these 15 are unaffected, and this one, why it's got some shade where the sun is currently performing lower. As the sun comes round, that'll recover, but importantly, it's not affecting these other panels. This is the absolute best solution, and it's because it's been specifically designed for our environment. So probably in 2 hours' time, it'll be raining here and the light might drop away. These panels are still going to perform. They also, aesthetically, they look great. They're an all black design. When you stand the panel up, it looks white because of the clear intersection, but actually when you have them on the roof, they just look pure black, and they're going to give you the performance that you need to make sure you get the best bang for the buck with your solar system. That's our panels. Now if you've got any questions about them, you want to have the spec sheet on them, just drop the office an email or comment below on this video and we'll be able to come back to you on that. What we're going to go and do now is look at the battery system, take a look how that's been installed, and then finally at the end of the video we're going to take a look at how we design this system, and also once it's live on the end phase monitoring system, because a further advantage of this system is that you can see every panel's individual performance. With our system, we can identify any issues with any panels, but more importantly, it's not going to affect the rest of the array. So I just wanted to show you the two panels that we put on this east-facing roof up here. So there's actually two panels on this sort of outrigger section of the property. And again, with a microinverter system, you can do this. You can place two panels or even one panel on its own because it's got an inverter behind the actual panel itself. So it doesn't need to have a load of voltage to kick a main inverter over. You could never do that with a DC system, but on a microinverter system, every panel is its own power plant. Now, the reason they have been placed there is if you pan behind you, again now sort of 10:30 in the morning, the sun is over there, and these two panels are in full direct sunlight of the actual sun. So they're going to be collecting energy, and as the sun moves round to the back of the property, those back panels are going to pick up the performance. So this is a real advantage of using this type of technology. When you combine that with these REA Fusion 2 panels, you're going to get the best system for your home. So we were talking before about the Giv Energy all-in-one battery. This battery actually features something called full home backup. So in the event of a power failure, the actual battery itself can flick over and power the home. But to do that, it needs to be able to look to the grid and pick up where the incoming supply comes in. Now, the battery on this property has been sited round the corner in the garage, which has meant we've had to run the tails from the incoming supply all the way to that battery's location. So this is our incoming supply here. We've run this Copex, and what we've done, we've had to dig a trench all the way along the front of the property, around this supply box, down the side here, and then what we've had to do is then go under the paving into the back of the garage to get to our battery. So it's a much more complex install than we'd originally envisioned, but look, it's what the client wanted. The client wants full home backup, and that's what you need to do in these scenarios. So we're in the garage, and this is our battery system. Now, this is the Giv Energy all-in-one. What we showed you before was we ran the main supply from the home to the gateway, and then the gateway is then attached to the battery. What I want to show you now, because I thought it's quite interesting, is how this battery is made up. So right here, we've took one of the cells out, which they are very heavy, but there's 4 of them. And they plug in basically like a drawer to make up the total capacity of this battery. But cover on this just sort of snaps on, and then you've got 2 little retaining screws that just go in. No, I'm so out of breath. I'm not a very fit person, but I've been on holiday. I suppose what's good about this battery as well is because the cells are sort of individual, from a warranty perspective, pretty easy to swap, really. I mean, it's almost a DIY job, although you definitely do not want to open one of these up without turning it off because it's very high voltage. You know, obviously batteries wear out over a period of time, and traditionally you'd have to change the whole battery, but with these you just buy new cassettes, and you know, possibly that cassette technology might improve over time, and maybe there'll be like a retrofit solution for them, but as it is now, it's a very, very good bit of kit. The guys are just doing what's called the Henley block now. So they're just doing where the incoming supply comes in, they're attaching that to like a high voltage junction box, and that'll give the power down the line to here. And then we'll be able to commission it. So I might take you through that process depending on how time goes. If not, we'll be back in a minute and we'll take a look at the gateway. We are now at the stage where we're going to start to do some commissioning, and the first thing we're going to do is this end-phase envoy, and we're going to do all of our microinverters, provision them, set the array out. But to do that, you needed to have collected off your microinverters all the serial numbers. Now, if this is ever your first end-phase job, I guarantee you will put all the panels down, put all the inverters on, and forget to take the stickers off and build your array. So don't forget to do this. We've used this very expensive piece of cardboard. You can buy these online. if you want to make your own, we have done. So this is our array. So this is our top 16 panels, and then we've got the 2 east panels here. The Enphase app is really easy to use. So it gives you this little feature, and you just go. But they're all scanned in now. So dead easy. When you do it on this as well, what's really, really good about it is you can't scan the same serial number twice. You can type them out if you want, but it takes forever. Just scanning them is much easier. So when the client logs into his Enphase app, he'll want to see which panels are which ones are performing well, which ones maybe got some shading. When you build the array, knowing the position of each microinverter, that's what dictates which panel is where. So obviously what we're expecting to see on this property is that top right-hand panel near that chimney may in the morning, or it should do in the morning, perform slightly worse than the rest of the panels. As the sun comes round, that'll fix. This is a microinverter system, so just because that one panel is having some partial shading and might have reduced performance, the rest of the array isn't going to get affected. Whereas on a DC system, it would be affected, it'll drag the whole thing down. Okay, so we're going to build a little bit of the array now. So our top left panel ends in 435, so that's going to be 435. The next one along is 792, so you just assign it, find 792, and essentially you just keep going and building your array like that. It gets easier as you go because once you've assigned a panel, it removes it from the list. So this one up here, this is the chimney panel, if you like, the one that's going to get the partial shading. So this ends in 980, so we'll come back to that later on to show you how the performance of that panel may differ from the rest of the array. So our next job now is to connect this gateway to the client's Wi-Fi. To do that, you need to put it into access point mode. So you press that button there and it'll light this green light up. And it's asking us now to join the Envoy. Just realised I've got one glove on. It's a bit wacko-jacko, that, isn't it? Failed, right. Okay, so this is our gateway. So when you've got the battery, which is down there, this is connected to the gateway, and the gateway essentially is the control mechanism for if the power drops, and it also controls the battery at the moment. I think Giv Energy are actually going to release it in the future where this is going to be an optional product. So the Tesla Powerwalls have gateways, but they're an optional accessory. The purpose of the gateway is this. The incoming supply from the grid goes into the gateway. It goes across a bus bar, which is an electrical connection, down to our load. Okay, and then the battery is actually wired straight in to the gateway as well. Now, if this sense that the grid had dropped, what it does, quicker than you could blink, is kick over to the battery. So it cuts the grid, and it'll kick the battery on to supply the property to the point where you wouldn't even see the lights flicker at home. Now, obviously this is only useful if you've got reserve charge in your battery. What you can do on the Giv Energy app is set a minimum reserve charge in the event that you're going to have a power cut. Now, if you live in a rural area where you get lots of power cuts, it's probably worth keeping the reserve charge. If you live somewhere like here where it's unlikely, although apparently it did happen a couple of months ago, you might want to keep a smaller reserve charge. Once the grid is restored, this will automatically kick back for you as well. Now, why this has to happen is if the grid dropped and there's a fault on the line somewhere, the reason this disconnects from the grid is that if someone was working on that line down the road and your battery is potentially discharging, or your PV system is discharging power into the grid, they get a shock, and obviously that wouldn't be great. So the purpose of this kit is to instantaneously switch on and switch off from the grid. So it's a really, really good bit of kit. It also comes pre-metered with your meters come pre-wired, so your grid and your PV supplies are all pre-wired straight into this system. So it's a really, really good bit of kit. We're going to commission it now, and we'll show you it working on the app shortly. Battery is done. We've managed to do the software update and the commissioning, which took about an hour and a half. We went to go and get a coffee because it was taking forever. A lot of these Giv Energy batteries are all on the old BMS. I think it was BMS 5. It now goes on to either 6 or 7. We've put this one on to 7. Same with the gateway. You've got to do the commissioning on both of the, the software updates on both of the products. Also, the N-Phase Envoy also needed an update, so the whole thing took a little bit longer than we'd like. But anyway, it's done. Wanted to show you something quick, which is our new stickers, which is probably really boring and completely insignificant to most people, but we quite like them. So come over here. Look at these. We get a lot of these where we're going outside and we were putting stickers on and they were coming off, which was a bit of a stupid idea. So we've changed now and we've got these, which are, that one's just come off.
Quite easy to pull off.
They're quite easy to pull off, you see, which is quite good. I didn't take the sticker back off that one. But there you go, it's designed to show you. Yep. You can see it, look. Oh. So you put them on there, push them on, then they don't come off. There you go. Battery isolator, Envoy. We've had them all custom made, look at this. You see that? Solar Envoy in here. All very, very good. And we've got a shutdown procedure as well. And obviously this is an REA system. So we've had those done from REA. Battery's done. This is your Wi-Fi dongle on your battery as well. You might see these on some of the Giv Energy stuff, but definitely on the all-in-one. This is a magnetic, the little antenna. It just does the Wi-Fi connection to your home router. This property, because it's in the garage, we've had to put a Wi-Fi extender in. Well, the client put it in actually, so it just makes sure you get a strong signal. Right, so we're done here now. The battery's live, the battery's commissioned, the N-Phase system is live and it's commissioned. If you look really closely, I don't know if you can see that. That's how you can see the performance of every individual panel. Now, this is on the engineer version of the app. That's our 2 easterly panels, and there are 16 on the rear roof there. What we're gonna do now is we're gonna head back to the office. I'm probably not gonna film it today because it's Friday. We've got to get from Birmingham to Warrington, so it's gonna be a nightmare. But on Monday or Tuesday, we'll log on, check how the system's performed, and we'll take you through how you can check and investigate every single panel's individual performance on the N-Phase app. Okay, so we made it back to the office. The weather was terrible on the way home and at the end of that first day, and it's still pretty miserable now, but what we have got is 4 days worth of data of the system performing. Now, as we said on the video shoot when we were there on the day, we designed this system in a particular way, and that was to get some morning production and try and get production throughout the day. So this is what you're going to see. If you have one of these systems fitted by Heatable, you'll get access to this high level data that you don't get with a normal system. So we've got 2 panels on the east array here, so they're going to capture the morning sun, and they're going to be supplemented by that Giv Energy's battery power from the night before to help cover any home loads. And as the sun comes round, it's picking up on these rear panels. Now, what you can see on this screen here is each individual panel, and like I said before, and I'm going to say it again, you don't get this on a standard DC hybrid system. You can only see the gross power production. So what we can see, these numbers here, are the performance of each individual panel, and as you can see, they're all pretty consistent with the exception of this east panel array, which only got 3.16 compared to its neighbour that got 3.45. Now, sorry, this is a 2-day period that we've got data over here for. The gross system production over those 2 days was 52.5 kilowatt hours, so really, really strong. But what we want to know is, why is this panel slightly underperformed? Well, because we've got this data, we can actually take a look and have a look at what was going on. So if we click in here, what we can see is on the second, so on the first full day, this panel only produced 265 watt compared to its neighbour, which produced quite a bit more. When we've taken a look into that, we've actually taken a look and realised that the grid profile within that particular panel wasn't actually set. It took some time to catch up, and that's why it underperformed. What's really important here is because that one panel slightly underperformed, it didn't affect the rest of the array. And with a DC system, that would not be the case. If you had a DC system, what you would see in your back end or your app or your software is just this screen here. So what you're producing right now is a gross net figure. If you're exporting it or consuming it in the home, what you would never know is your system underperforming for any particular reasons, or if you had a panel go out, you wouldn't be able to find from the app which panel had actually failed because there isn't individual panel monitoring. Where this becomes an issue and where we have some DC systems installed is some days it's super sunny, super bright, you'll take a look at your app and think, why am I only doing a kilowatt? With a DC system, you wouldn't be able to find out why you're only doing a kilowatt. With this Enphase system, with the REA Fusion 2 system, you can log in, have a look. Oh, I've got a panel, it's got bird muck on it, or whatever it is, that's what's causing the underperformance. So from a diagnostic perspective, it's really useful for us as engineers here in the office to monitor and make sure your system is performing at the maximum output. And also for a client, if you have a fault or you have underperformance, it's really easy to identify which panel is actually causing the problem. And finally, again, importantly, if there was one panel that failed, with this system, the other 17 in this case are going to be on and performing, whereas with a DC system, that whole array is going to shut down. You're going to be looking up at your roof going, which one of these is causing the issue? So if you're interested in getting a quote for one of these systems, and you can do it online, you don't need to have a salesman in home, just head over to heatable.co.uk. You can draw your roof, you can play around with it, you can see your savings, and you can get a fixed price to have this kit installed at your property.